Welcome back, guys. Today's video is going to be on the concept of valence electrons. Now, this video is going to go hand in hand with my other video on ionization energies, which we're going to talk about at the end of this video. So make sure that you're watching both of these videos to have an understanding of both of these concepts. So what are valence electrons? Well, valence electrons, their definition are the outermost electrons in a shell. Now, what does that mean? Now, looking at this periodic table, which I made a rough sketch of, and these atoms over here, we can get a better understanding of what I mean by valence electrons being in the outermost shell. So if we take a look at lithium, why did I draw lithium the way that I did? So we can see that it has two shells, right? So every time I draw a circle, that represents a shell for that atom, right? So there's two shells or two circles that I've drawn here for lithium because lithium is in the second row in the periodic table. So not columns, we're talking about rows here. So as we go down each row in the periodic table, we're going to add another shell. So hydrogen and helium would be drawn with one circle. Lithium, beryllium, boron, carbon, and so on and so forth in that second period are going to have two shells. So fluorine we can see has two shells because it's in the second row of the table. And if we take a look at sodium, I drew it with three shells. 1, 2, 3, because it's in the third row down on the periodic table, right? So we know that valence electrons are the electrons in the outermost shell. Now, how can we use the periodic table to tell us how many valence electrons an atom would have? Well, if we use the table, we can use the columns to tell us how many valence electrons an atom has. So hydrogen, lithium, sodium, and so on down the first column, they're going to have one valence electron. And if we go down the second column, that would be two valence electrons. Now we're going to skip over the transition metals. They don't follow this rule. When we pick back up at boron and aluminum in this third column, they're going to have three valence electrons. And as we keep going, right, we can see oxygen with 6, fluorine with 7, everything in that column with 7, and then the noble gases in this 8th column are going to have 8 valence electrons. Now, just remember, when we talk about valence electrons, that means that if lithium is in this first column, that means it's going to have one valence electron, therefore one electron in its outermost shell. So let's look at lithium and compare it on the periodic table to how I drew it over here. So lithium, again, it has two shells because it's in the second row on the periodic table, right? The rows go across and we can see that it's the second row because as we go down, we're in the second row, right? So it has two shells, it's in the second row. Now, lithium has 3 protons because it's the third atom on the periodic table, right? So that's why I drew it with 3 protons in the nucleus. It's the third atom on the periodic table right here. Now, it has 3 electrons. Now, we're going to have to talk a little bit about why I drew the electrons the way that I did. Now, it has 2 shells, and it has 3 total electrons. However, its first 2 electrons are its core electrons. So core electrons are the opposite of a valence electron, right? Valence electrons are going to be the electrons on the outermost shell, but core electrons are those electrons on the innermost shell. So it has 2 electrons in its innermost shell because we can see from the first period, its first 2 electrons come from the electrons in the first period, right? And you make sure to check out my video on electron configurations to get a better understanding of why those electrons are where they are. But if we can see, its first 2 electrons come from these 2 right here. Its third electron, we're going to now come down from the first row to the second row. It's going to get its third electron from here, and there's only going to be 1 electron in this second shell. So its first 2 electrons are its core electrons from the first row. It gets its third electron, right? Its outermost shell electron, or its valence electron, from this second row. So that's why we drew it the way we did. Now, if we go to something like fluorine, why does fluorine have 1, 2, 3, 4, 5, 6, 7 valence electrons in its outermost shell, its second shell in this case, right? So why is that the case? Well, fluorine is the 9th atom on the table, so it has 9 protons, and we expect it to have 9 electrons. Now, why are they in the places that they are? Well, its first 2 electrons, again, are its core electrons coming from the electrons in the first row. And then it has 7 valence electrons, 1, 2, 3, 4, 5, 6, 7, right? And we can use the columns on the table to tell us that it actually has 7 valence electrons, right? So in its outermost shell, its second shell, right? It's in the second row, we're expecting it to have 7 valence electrons. And we'll do one last example, and then we'll talk a little bit about ionization energies and how that ties into it, right? So we have sodium. Sodium has 1, 2, 3 shells, right? That's because it's in the third row of the periodic table, right? 1, 2, 3. So it's also number 11 on the table. So it has 11 protons and 11 electrons. Now, why did I arrange them in the way that I did? Well, its first 2 electrons are its core electrons coming from our first row, right? Then our second row, or our second shell right here, we see has 1, 2, 3, 4, 5, 6, 7, 8 electrons. That's going to come from 1, 2, 3, 4, 5, 6, 7, 8. 8 more electrons right there. Again, make sure that you're brushing up on electron configurations. Now we get all the way past our second row. It has 1 electron in its outermost shell, its third shell, right? We can see that electron is right there. We could also have used the periodic table to tell us that sodium has 1 valence electron, or 1 electron in its outermost shell. So that is valence electrons. Make sure you understand that valence electrons are the number of electrons that it has in its outermost shell, which we walked through. Core electrons are electrons on the innermost shell of an atom. Now, one last thing I want to go into before I conclude the video are ionization energies and how it ties into this. So remember, I did make another video on ionization energies that you should check out. So these are the ionization energies of lithium, right? And remember, lithium has 3 total electrons, therefore it has 3 ionization energies. And ionization energy is the amount of energy it takes to remove an electron from an atom. And so we see that its first ionization energy is 0.86 attajoules. Its second and third ionization energies seem to be much higher in value, right? They're 12 and 19. So there's a big jump from this 0.86 to then 12.1 and 19.6. Why is that the case? Why do we have to put in so much more energy to remove these second 2 than the first one? And remember, we're putting in energy to rip away that electron because it wants to be attracted to that positively charged nucleus, but we have to put in energy to remove it. So why the discrepancy between these values? Well, this ionization energy is very small because it's not going to take as much energy to remove this outermost valence electron. If you were this electron, while you are attracted to this positively charged nucleus, these 2 core electrons are much closer to that positively charged nucleus. Therefore, it's much harder to remove those inner core electrons. So you're going to have to put in more energy to remove these core electrons than you are this very, very outermost shell electron, right? So just as a summary, ionization energies, how it ties in. The ionization energy for a valence electron is much lower because that is the electron in the outermost shell. It's easier to remove that because it's farther away from those positively charged protons. If we saw something like sodium, it would be much harder to remove these electrons, right, than this outermost valence electron. And the same thing goes for fluorine. So thank you for watching, and make sure to check out my channel for more videos.